Hi class, this is Dr. Bear, and I am going to go through and share our full hypothesis testing steps for our temperature problem. So again, we have problem solving, and then we've got our independent variable was the room you were doing your problem solving in is different degrees, and this is made up data. All right, so just a review of the basic steps. First, you're going to write out your hypotheses. Remember that you need your null and you need your research hypothesis. Then you would calculate your degrees of freedom, and that would help you use the F distribution table to get your critical boundaries, or we can call them critical regions or critical values or cutoff scores. Then you're going to go through all the steps to get to your F. Once you've gotten your F, you are making comparisons between your critical value or cutoff score or critical boundary, critical region, and what you got in step 3. Then you are making your decision. Remember, your decision has 3 parts to that statement. You're going to tell me if you reject the null or fail to reject the null, if it's statistically significant or not, and then give me context. You're then going to calculate effect size. For ANOVA, we are doing eta squared. And then you would indicate to me if you would run a post hoc or not. Again, we reviewed the post hocs being the Tukey and the Chaffee and the Bonferroni, but we did not learn those calculations. All right, so let's go on to our problem. So here is our data. Again, we had gone through where you get all of these different numbers. But these are the numbers and the information that we're working through. So I'd like you to pause and I'd like you to actively work through this problem. And so you are going to first set up your step 1, doing your null hypothesis and your research hypothesis. Remember, only one of these has words, or both have words, sorry. Only one of these has math. So go ahead and pause this video and then put that in there. And then press play and move on and see how you did. So for step 1, your hypotheses, again, we can only use math for the null because this is an omnibus test. So this is what it might look like. Again, for context, I want you to be specific so there's no differences in problem solving depending on the room temperature, and then at least one group will be different in problem solving, comparing room temperature. Again, bringing in specific context from the problem. Then we are going to go through and calculate your degrees of freedom. So go ahead and pause the video. Look up those formulas for degrees of freedom between and degrees of freedom within. So you've got your k minus 1 and you've got your n minus k, or n minus 1 plus n minus 1 plus n minus 1. So go back and look at your n's for our 3 samples. And we also are given our total n, but that's the same as adding up the 5 plus 5 plus 5. And you have 3 different conditions, so your k equals 3. Okay. So if you had gone through and again looked at that, we are going to then use those 2 pieces of information for your between and your within. Remember, degrees of freedom total is another part in the ANOVA table, and that would be degrees of freedom between minus or plus degrees of freedom within, or n minus 1. But we don't use degrees of freedom total for our table. All right, so then you are going to go ahead and use your degrees of freedom between and degrees of freedom within and look at your F distribution table. So you should have gotten degrees of freedom between was 2, degrees of freedom within was 12, so 4 plus 4 plus 4, or 15 minus 3. If you then looked at your critical region table, you will have gotten 3.89. So 3.89 is our cutoff score for that, which we're going to compare with how we get our calculations. So you are now in the process of working through all the different calculations for to get to our F. So we've got to calculate our sum of squares. You've already calculated your degrees of freedom. And then you're going to calculate your MS, which is our mean squares, which is our variance between, our variance within, and then we're going to get to our F. So let's review our formulas. So our formulas for our different ones are sum of squares within, sum of squares total, sum of squares between, sum of squares between. We need to use our sum of squares total. You are given G, you are given big N, you are given sum of x squared, and you are given the sum of squares for each one of our three temperature conditions. Go ahead and take a moment to write all of those numbers down. Again, going back to this table. So you need sum of x squared, you need G, you need big N, you need sum of squares 1, sum of squares 2, and sum of squares 3. So go ahead and take a moment and calculate all of those and pause the video. And then after you're done, go ahead and check your work. So let's see how we did. So you would have gotten 46 for our sum of squares total, 16 for our sum of squares within, and then 46 minus 16 is 30. You have already done most of the calculations for degrees of freedom between and degrees of freedom within. Now we just need degrees of freedom total. So just for a review, we had gone through and already calculated these. Again, you had gotten 2 and 12. We could do 12 plus 2 equals 14. We could also do 15 minus 1 for degrees of freedom total. All right, so there we go. Again, you already calculated 2 of these in your step 2 to get your critical value. All right, so let's start putting this together. This is where we're at with our ANOVA table. So our next step is now to calculate our mean squares between and our mean squares within. There are only 2 mean squares. There is not a mean squares total. Okay, so let's go ahead and pause and go ahead and do those calculations. Again, for each one of these, again, we're moving towards this area. We're going to have a value for mean squares between. We're going to have a value for our mean squares within. And we're using these formulas. So go ahead and take a moment to do those calculations. So let's see how we did. If we take the 30 divided by 2, we get 15. If we take the 16 divided by 12, we get 1.33. We are now working towards F. F is the ratio of variance between over variance within, or MS between over MS within. So there you go. You are going to plug and chug these two things. Again, we use MS for our version of the variances we're calculating for our F, but it is variances. Although ultimately you are comparing group differences for your hypothesis test and choosing an ANOVA. So take a moment to plug in that 15 and that 1.33 to get to your F, and then let's see how you did. So when we calculate that 15 divided by 1.33, we get 11.28. We are now comparing that 11.28 to our critical value from step 2. Our critical value from step 2 is 3.89. So what decision would you make? Again, with step 4 decision making, you are going to give me 3 pieces of information: reject the null or fail to reject the null, statistically significant or not, and context. What does that mean according to my problem? The other thing that I'm going to want you to do is go ahead and complete that ANOVA table. So this is what it would look like. Again, you only have mean squares between, mean squares within, and that gets to our F. So let's see how you did in your step 4. Decision making. Again, take a moment to pause, write out those 3 pieces for step 4 with making a decision, and then let's check your work. So again, using APA, this is how it might be written up. Because we have p less than 0.05, that means we had a statistically significant finding. Statistical significance connects to the decision of reject the null. When you have p less than 0.05, remember that means it is significant in any test statistic that you're running. So the next step we are going to do is effect size. So effect size, remember, we have a new formula for this. It's interpreted like R squared, and you are going to go ahead and calculate from information you used in your ANOVA table. So you would be using sum of squares between over sum of squares total. The value that you get is percentage of variance accounted for. So percentage of variance in problem solving accounted for from temperature scores. So go ahead and take a moment to make those calculations. Again, when you use R-squared, you are going to follow these three guidelines. If you have a number that's less than 0.01, that means you have no effect. Again, we can make comparisons to effect size to our decision making to identify if we have probable type 1 error or type 2 error. So go ahead and make those calculations. Remember, 30 was degrees of freedom between and 46 was degrees of freedom total. So take a moment to calculate your eta squared and check your work. So you can pause the video and then unpause when you're ready to check your work. And if you did 30 divided by 46, you got 0.65. 0.65 means 65% of the variance that's going on in problem solving is accounted for, attributed from differences in temperature. 0.65 is also in that large range. So I would say it's a large effect, and then I could do my interpretation. The next thing that I want to identify is post hoc. Well, it's very exciting that we have differences in problem solving scores dependent on room temperature, but I need to know where the differences lie because F is just an omnibus test. A significant F tells me there's group differences, but does not tell me where those differences lie. All right, so I do need to identify if it's appropriate for me to do a post hoc. So again, here is our decision making when we're going through and using this, and we see differences across our three different groups. And then because we rejected the null, we are going to have a post hoc. And I had explained the post hoc findings in class, but this shows the results for the room temperature study.